My name is Jiri, and I will be speaking today about dependency injection in general and especially in React. Why do we need something as like dependency injection? Well, when you're writing reusable code, you always need to make a quite complicated choice whether you are making your code as a big chunk of monolithic, highly opinionated code where you just plug it in and it works, or you're making a universal set of large amounts of components where the user is then required to assemble those together. There are pros and cons of both these approaches, and it's very, very hard to find the right balance between the two. So let's just go through some of these pros and cons. So the opinionated piece of code is easy to plug, right? And then you just plug in and you just enjoy it. While in the universal one, you first need to build something, assemble the components, connect them together with your own wiring, and then suffer the consequences, right? So in the opinionated way, well, opinionated basically means that it tells you how to do things, right? So the best practices are included. In the universal way, you need to find out your own way. You can get an inspiration somewhere, but well, it's your choice. That connects to the next part, right? If you don't like the opinionated piece of code, then you just need to throw it away because there is basically no way how you can customize it. If you have a super universal one, you can tweak it exactly to your needs, but it costs. So the result is that in opinionated version, you basically enjoy it first because you plug it in and it works, and then you find out that it doesn't really suffice sometimes, and so you feel the pain. And in the universal approach, it's the other way around. In the beginning, you feel a lot of pain while you're trying to assemble everything, and then eventually, when you survive, you feel the joy, right? The complexity also varies. I mean, if you have an opinionated piece of code which just plug in, it can be as complex as needed, right? Because everything is hidden inside. As long as the public API is reasonably structured and comprehensible, then it's okay. With the universal approach, well, how many components can you have? And ask the user to assemble those. 10, 20, really depends on how these are wired together, but you really need to keep it in a certain level. So this is just an example diagram, very rough one, of both those approaches. You have a big box of some, let's say a black. Is it still okay? Oh. Okay, so in these diagrams, the red pieces are your custom code, or basically application code. And the blue ones are the ones that are provided by this reusable chunk of code in library, let's say. So in the opinionated way, we have a big chunk of something. We don't really care what is inside. It just works, and we plug our application to it, and it works. In the universal way, we just have the little pieces, and we need to connect them together. And sometimes we need to provide our implementation of some pieces, right? So that's why the red is much more heavier there. What if we could combine these two approaches? We have this monolithic chunk, and we inject something right in the middle of that monolithic chunk. So we turn this piece of code into our own, right? We just replace something. And that's exactly how dependency injection works. It just says you can replace any piece of any component that we are publishing through the dependency injection framework, as long as you comply to the signature, to the API that it really represents. So as long as it accepts the same actions and emits the same actions, it's free for you to choose your own implementation. So that's how dependency injection works in general. I guess it's just basically restating the obvious. So why couldn't we do the same? Well, we suffer the same issues in React, right? If you're building a React library, you either need to choose one component, a single opinionated component where you just plug in and it works, right? For example, a to-do list. So you would have a to-do list component that you plug in and it works. So you might be connected to a database, or to a Redux store or whatever, and it works. And or you choose to go the universal way, so you prepare a bunch of components which the application is required to assemble together. So again, the more flexible we go, the more complicated the library is. And in this in this universal way, there are basically two ways how you can do that right now. One is composition and one is configuration. People used to do a lot of configuration, so there was like a huge amount of props where you can define the behavior of your whole component tree, basically, because the props are passed down until the very end, leaf of your component tree. And recently, people started realizing that this is short-sighted, so they moved to this composition way of thinking. So they have the components, and that they let you build those components. Both of these approaches have their pros and cons again, but I consider them both to be this universal approach where you have a lot of things to configure in order to make it work properly. And there, well, we could apply the same approach as we are using in other areas of tech engineering, right? We again can also use the dependency injection in React to have a top-level component or few top-level components that we just plug in somewhere. And if we need to change the functionality of some components down the tree, we can just replace those components and replace the functionality. So the overall thing will still work correctly and out of the box, while we can tweak the little pieces. So we need to basically push the components down from the root of the tree down to the leaves, right? Which, well, that's what Context API does. So we can use it. And I'm going to show you how we use it on configurators and how you could use it as well. So let me just prepare this. No, go away. Go away. Okay. So I have prepared a very, very simple application. It's exactly the TodoList, actually a to-do manager, because you can create and remove to-dos there as well. So as you see, it's very simple to-do list where you can toggle state of those to-dos. You can remove those. You can add something. And you can also edit something, right? That's basically what it does. As you can see, the component tree is pretty clean. Now you have the root application, then you have the to-do manager, to-do list, to-do item, and the little things that are inside. So how do we now utilize the dependency injection? Why should we actually use it? Let's say that we don't like this checkbox here. It's pretty ugly, rosary. So we want to make it stand out a little bit and make it nice. So I want to make it, I want to turn it into a fancy checkbox that my colleague Honza actually created for one of our projects that we are doing. And for that, we need to make the components replaceable through dependency injection. So how do we start? First of all, the components, if I look into the to-do manager, for example, this is the actual state, what you see on the screen. So normally, it's like a bunch of components which are being rendered as children, right? And the components are imported from other files. So you can hardly replace those components when they are hard-coded, well, where they are actually imported from their files. So what we need to do as the first step is to make sure that we don't import those. So for that, we just create a hook which will return those components, and we will use it instead of the import. So we prepare the components first as like an object. So this is basically key value pairs where the key is the name of the component and the value is the actual implementation of the component. So as you can see, we just imported those components here, prepared the object, and then create a simple hook that returns those components. So, and then in the files which are using those components, we make these changes. We remove the imports because we don't need them, and we use this hook to retrieve the components. So this is basically the only change that you need to do in order to make your your components dependency injection able. So we do that for all. We do that for all the components that are using other components. Everything that is in our component palette is now served through the component palette. So let's just try that it works. I will use Git to move through the steps, so I don't need to write that code because it would be quite slow. So I'll refresh that and see if that works. It works. Cool. So, but it doesn't change anything, right? It's still, we are still taking the components from the files, basically, right? Because we import them and we just forward them through the component palette. So the next step is to use the context API. So instead of directly returning the default components, we create the context, and this use component palette hook will read the data from the context. It will read the components from the context, right? So that's what we do, and we initialize the context with the default ones. Again, this should not have any effect on the output because we're still not overriding the components. We're just using them from the context, but it works. So next step is to have this fancy checkbox here, which is basically an SVG with some animation, which you unfortunately won't see on Meet because it's too fast. And you see that the checkbox actually implements the contract that the regular checkbox creates. So the checkbox itself, the component checkbox, uses some props, checkbox props, and we implement the component with the exact same props. That's important because the component that actually uses this one is aware of those props, right? And it feeds the props. So we need to comply to this contract. So what we do that, we use the same props here, but we replace the content entirely. And now we just go. We just need to make sure that we can override the component. So what we actually want to do, what we want to accomplish is something like this. So instead of mounting the to-do manager directly, we will wrap it into some kind of a provider. And this provider will make sure that it will override the components, the default ones, with those that we specifically ask for. So what we want to say here is that anytime to-do manager requests a checkbox, it will be fed with fancy checkbox. And that we can do quite easily using the context API. So I prepared a component. You can call it any way you want. I call it override components, which just takes components, which is basically a fractional part of this component palette that we just defined, and the children that it renders like any other provider. So what we do here, we take the original components, well, it's basically the components that are already in the scope, and we merge it with those that we want to use as overrides, and we fill the value of the context using the provider. So next, if this use component palette hook is used inside, it will fetch the components which are already overridden. So let's see if that works. Boom. We have a fancy checkbox here. Let's see if you see the animation. No, you don't. Okay, but it's really fancy. So as you can see here, the resulting component tree changed. So we now have the to-do manager, but it's not directly under the app, right? We have these override components and the internal provider, which is providing the fancy checkbox. And you can see that instead of checkbox, we are actually rendering this fancy checkbox right here. So what's the next step? Well, I increased the size of the checkbox, and now the buttons are going a little bit too far to right. So let's make them smaller. Let's replace the buttons. We will make them display only abbreviation under the first letter of the label, and we'll let the label be displayed as a tooltip. So we'll create something which I call concise button. So it's very, very simple. Like the title is fed with the label, and we display only the first character. And the only thing we need to do is to register that button. So we already have these overrides here, and we just add the button. So we replace button with a consist button. And now let's try whether it works. Okay, it does not. Why? Well, this is a typing issue. This is something you need to keep in mind when you're doing this stuff, because what I used here for the consist button is an anonymous function is basically a constant, right? With an arrow function which is typed as functional component. A functional component internally is defined as that it can return a React element or null, right? But my function, my original button here, which is here, my original button always returns React element. So it's typed differently. So these two types are not interchangeable. You cannot assign the functional components to a type which was defined by this piece of code. So for that, we just need to do a little bit of generalization, which is fortunately possible with Typescript. So this is kind of a magic. Typescript allows you to define so-called mapped types. So basically, this piece of code basically does that. It goes through all the properties here and says, okay, is checkbox assignable to component type, which is basically an abstraction over any kind of component in React. So it can be a functional component, it can be class. So it just says, okay, is it assignable? If yes, then treat it as a regular component type. And the regular component type is free to return null or React element. It can or either of those. So we now abstract it, and we can now assign properly the button. So it will work, hopefully. Oh, I need to refresh. Yep, it works. So as you can see, we have the edit button, the delete button, pretty small. There is an unfortunate side effect. We also, diminish this add new entry, which is not really understandable right now. And this is neither, right? So what we want to do, we want to limit the scope of our overrides to a particular piece of our code. We can do that easily because the implementation of this override components that we did is nestable. You can nest it, and that's what we are going to use. So in order to inject a component to a part of the tree, we need to use these override components somewhere deeper in the tree. We want to probably use it on this to-do list, because in the to-do list there is only to-do item, and the buttons which are inside should be small. We could also do it on the to-do item, but let's do it on the to-do list. So what we need to do here, we need to basically override the to-do list and then inject our overrides for everything that is within the to-do list. So for that, we just create a new component called concise, to-do list, and we override the button there. So as you can see, it just takes the default component, which we already defined somewhere, and it renders it with the same props, but only wraps it in with the overrides. You have to be very careful here not to use the to-do list from the component palette, because if you would do so, you would load again consist to-do list, and you would end up in a recursive, endless rendering of the same component. So this one is really loaded, really imported directly from the particular file. Fine. So when we do so, we also need to remove that button override from the top, from this override, right? And we need to add this to-do list override. And that's basically everything that we need to do. And if we do so, we should end up with a correct result. So the components within the to-do list are overridden, so the buttons are small, while the ones on the editor are still big. And that's what we wanted to achieve. So despite that this override components is pretty simple, it could be kind of tiresome to implement it in each project that we are doing. And that's why where is it? That's why we have a support for that in the spicy hooks package. So if you're interested, you can just plug it in using this create use dependencies, which just creates the hook, and the hook also itself serves as kind of a way to override the component. So instead of your own component, you use component palette dot override, provide the values that you want to override, and it works the same way as if you are implementing it yourself. We can just drive, and it works. So that's basically everything from the demo. I just wanted to tell you that there is a repository in GitHub under my account, which has exactly those steps. So if you want, you can take a look there and learn more. And now back to the slides for a while. So what are the takeaways? What we actually can do with context API and dependency injection? There's pretty low overhead in making your existing code base injectable or replaceable. You basically just replace the imports with the usage of your custom hook or the hook provided from spicy hooks. It is the type safe, right? You saw that if we change the signature of the components, it stops compiling. I can show you maybe. Oh, no, you get the picture. So it will stop compiling. So you see that you need to provide the component with the right props. So whenever the actual library changes, the usages need to be accordingly adjusted as well. So because otherwise it won't compile. As you saw, we can use scoped or basically nested overrides, which also works fine thanks to the context API, which is basically meant for that. So that worked fine. What doesn't, or what are the cons of this approach? First of all, the code splitting, right? If you have a bunch of files and you let the Webpack, for example, to compress it, to bundle it into several bundles using dynamic imports, and it works out of the box. If you do this way with component palette, then you're basically importing everything to a single object, right? So it can't be broken down into several bundles. Well, but you can still create multiple component palettes, right? So theoretically, you can make your code more granular. Big components are not working. Well, yeah, you should keep your components very simple and have more of them, because if you want to replace something, you should be able to do it easily and not copy paste like a bunch of markup and logic. If there is a big amount of logic in the component, it's kind of useful to extract it to a hook. Let's call it use my component logic hook, whatever, and all the logic will be there. And then whenever you want to override the component, you just use that hook again, and you get the same logic. You just change the markup. What I show you, there was no possibility to inject logic, right? It was only the full component always. So if you wanted to inject some kind of a custom logic, you needed to override the full component. But what if you do the same approach for hooks, for example, right? You could do it the same way. It doesn't need to be a component. The dependency that is pushed through the dependency injection framework can be anything. So if it's a hook, why not?